Good evening, everyone. Thank you all for joining us tonight. We're thrilled to have you here to share our journey. This evening, we'll take you through our vision, the challenges we tackled so far, and the innovations we're building for a cleaner future. Let's begin with the story of hydrogen. For over a century, hydrogen has been primarily used in industrial applications as a fuel for large-scale manufacturing processes. Yet, its potential goes far beyond that. Clean, abundant, and able to store vast amounts of energy, hydrogen is uniquely positioned to address the world's growing demand for clean energy solutions. Today, hydrogen is emerging as one of the most promising tools in the fight against climate change. It offers a zero-emission alternative that can support industries ranging from manufacturing to transportation, and especially the maritime sector, which has historically been difficult to decarbonize. And now, we are taking this technology to the next level with liquid hydrogen, a cryogenic form that allows for greater energy density. This is because the maritime industry is facing a significant challenge. It needs a powerful, sustainable energy source that can operate at scale. With rising emissions, warming oceans, and the degradation of marine ecosystems, the stakes couldn't be higher. Clean energy solutions for this industry are not just necessary, they are urgent. Our solution is hydrogen. Hydrogen is versatile, abundant, and most of all, clean. With liquid hydrogen, it allows us to store even more energy, drastically reducing its volume, and power vessels without compromising on performance. It's more than just another fuel. It has the potential to reshape how we power our world. Our story with sustainable energy began nearly 2 decades ago. In 2005, we started as a solar boat team, pioneering renewable technology on water. For over 15 years, we demonstrated that renewable energy could power vessels effectively, even in the most demanding environments. But in 2020, we took a bold leap forward. Recognizing the growing potential of hydrogen, we transitioned to building hydrogen-powered boats. This marked the birth of the TU Delft Hydromotion team as we know today. A group of passionate, innovative students dedicated to proving that hydrogen-powered boats are not only feasible, but also necessary for a more sustainable future in the maritime sector. Let's take a look at our history.
We are the TU Delft Hydromotion Team 2025. a passionate, multidisciplinary team of 25 students united by one shared mission: to drive the maritime industry towards a sustainable future. Our journey is built on the foundation of those who came before us, pioneers who redefined what's possible in maritime technology and sustainability. For nearly 2 decades, we haven't just built boats, we've written history. In 2005, a group of students from the Delft Waterbike Technology Project was approached with a bold challenge: to build a solar-powered boat capable of competing in the Frisian Nuon Solar Challenge. Driven by curiosity and a passion for innovation, they took on this task, designing and building a solar-powered boat that not only competed, but exceeded all expectations. Their success didn't just win the race, it ignited a movement.
Well, this team started just out of an idea, coming up with, I think it was Wibbe Ockels who started off an idea to have a sort of mimic of the Solar Challenge in Australia. There used to be a very famous Dutch ice skating tour around the 11 cities of Friesland. However, that's back to 1996, I believe. And there are numerous of variants with bicycles, I think rowing, and we also did it with a solar-powered boat. Yeah, well, in this case it was quite quickly transforming into more than full-time, because there was a date when the whole thing had to be ready. And basically it started off with just an idea and some components. Good luck with it, get it together. The foundation of the whole idea was based on sustainability, showcasing the possibilities. And I think for the maritime industry in general, it is a huge advertisement to show what young people are capable of, what this industry can be capable of, and how to bring all types of ideas together. I already like it to have founded something where a lot of people can be very enthusiastic on and develop a lot of things that will at least bring joy to a lot of people, and maybe in the long term also some developments that will help the world forward.
Inspired by their achievement, new groups of students carried the torch, refining and evolving the original idea year after year. What started as a one-time experiment became a legacy of pushing boundaries in sustainable maritime technology, marking the birth of the TU Delft Solar Boat team. Over the next decade, the team continued innovating. In 2008, the boat won the Frisian Solar Challenge again, with a lead of 3 hours. This boat had a very small underwater hull with a depth of only 10 centimeters, which made the resistance minimal. The 2010 team were the first to implement our iconic hydrofoils, lifting the boat out of the water to reduce drag and dramatically increase speed. The next teams continuously innovated on the hydrofoils and the solar panel system. By 2016, the team reached a maximum speed of 55 kilometers per hour. The 2016 team was also the first to participate in the race in Monaco, where they finished second. The team of 2019 built our first trimaran. It was a modular design with a 28 square meter solar deck, making it our largest and most advanced boat yet. This innovation led to a historic victory as world champions in the offshore class of Monaco.
So in 2019 we were upscaling the boat, mainly the reason because we wanted to show the maritime industry that we could also, could conquer the waves, we could cross the ocean. We really wanted to show that we can really use the green energy in the offshore industry. A lot of my team members are also still in the maritime industry and working hard to make the dream that started kind of here to continue that, and then really in the maritime industry so they can really make an impact. It's a big step to take, and the only way we can help is show what the possibilities are. And if we can do it, then show the world you can do it as well.
In 2020, as the world slowed down, the TU Delft Solar Boat team kept going. Faced with the challenges of the COVID-19 pandemic, the team found creative ways to continue innovating, and their boat could sail on only the power of a single water cooker. Instead of competing internationally, they organized their own race on the Ketelmeer, demonstrating resilience and innovation, even in uncertain times. In 2021, the team took a bold new direction, transitioning from solar to hydrogen power, adopting a new identity as the TU Delft Hydromotion team.
Yeah, the question, why did we want to change to hydrogen? I still remember that we were in the office discussing our scope for our year in 2020, and we were discussing, oh, do we want to go to hydrogen? Yeah, we did really want to stay relevant for the maritime industry and how they can move forward towards a sustainable future. Yeah, everyone was it was a very, very big boat, because we recycled the boat of the 2019 team to also really put their focus to get the hydrogen system working all year. And yeah, I still remember that everyone was it was 8 by 6 or something. It was really massive. Eventually thinking back that we were in Monaco at the end of the year with a working hydrogen powered boat that even did fly, that was unbelievable actually if you look back at it. Yeah, I think definitely all the student teams were also very excited to see how everything would play out. But also, of course, every team is working on their own project in that year. But our technical universities in Europe were also considering, hey, how do we stay relevant? Are there other things that we can try? So it sets an example that you can indeed take a big step, make a transition in 1 year. It also sets an example for the maritime industry. Of course, they cannot do it in 1 year. Their ships are much bigger, but it shows the potential. And if you put your mind to it, that a lot's possible with the right people together.
The following teams refined this vision further. In 2022, avoiding monohull demonstrated hydrogen's endurance capabilities by winning Monaco's endurance race. In 2023, the team turned the tide with a foiling hydrogen-powered boat, once again becoming world champions in Monaco. In 2024, the team created the next wave and set out on a new challenge, crossing the North Sea.
For us, we thought we want to show that hydrogen also is applicable for the big ships on the open sea. And we wanted to show harbors we came across, some more unexpected than others, that hydrogen is also applicable in the maritime sector. The Dream Team is about setting new boundaries. It's about being ambitious like you do as well. So the previous teams were really enthusiastic about, you're going to do something different. That is awesome. Let's go for it. We're going to help you. Engineers of Hydromotion dare to dream, as in no goal is big enough, crossing the North Sea, winning Monaco, letting boats fly. The difference between an engineer of Hydromotion and maybe other engineers is they dare to dream, they dare to inspire, to innovate.
Now, as a team of 2025, we're taking the next step to fuel the future, transitioning from compressed hydrogen to liquid hydrogen.
I think we're taking a big step forward again. In 2020, we switched to hydrogen. That was a big step at that time, and now we're seeing that this is the next big step to take. And of course, it has been hard, because sometimes we've gotten some calls from people and they say, well, you're not going, it's just impossible. And it's been very difficult, but we talked about it and we just went on, and right now we're making incredible steps to finally succeed. So obviously we are a dream team. So it means that we need to set goals that are so ambitious that for some people it might seem impossible. But if we set goals that are so ambitious that people think, well, you're not going to make it work, that's not possible, and we do make it work, then that's what shows, hey, there's more possible in this world than we thought about before. And I think that's incredible that we do that.
For nearly 2 decades, the TU Delft Solar Boat team, now the Hydromotion team, has been at the forefront of innovation in sustainable maritime technology. Each generation builds on the achievements of the last, transforming bold ideas into tangible advancements. Together, we fuel the future of the maritime industry, paving the way for even greater breakthroughs yet to come.
We see ourselves as pioneers in the energy transition, working at the forefront to prove that hydrogen can help fuel a sustainable future. Our mission is about much more than designing a boat. It's about demonstrating that the technology and know-how to drive change already exist. We hope to inspire others in the industry and beyond to follow our lead and helping in building a cleaner world. As you might have heard before, we call ourselves a dream team. But what is it that makes us a dream team? It's our shared vision, our collective drive, and our diverse skill sets. We are a group of 25 passionate students from various fields, united by a commitment to sustainability. Together, we're not just building a boat, we're building a legacy of teamwork and progress. And we are creating a future we can proudly pass on to future generations. After having explained what we have been doing so far, and mostly why we have been doing this, we are left with one important question. What's next?
In 1 year, we will design, build, test, and race a foiling boat powered by liquid hydrogen. With its high energy density, liquid hydrogen offers a sustainable and scalable energy solution. And to demonstrate this, we will participate in the Monaco SeaLab 2025. With liquid hydrogen, we're taking a bold step toward a greener future. And our participation in the Monaco SeaLab will showcase the potential of hydrogen on a global stage. But this journey is not just about racing. It's about inspiring change by proving that alternative energy can be a viable solution that can meet the industry's demands. Together, we aim to push the maritime world toward a cleaner and brighter future. We are a team of 25 passionate students, united by the vision of creating a sustainable future. Together, we have set aside our individual studies to create something extraordinary. Behind our vision are 6 specialized departments, each playing a critical role. First, we have the Hull and Body department. They focus on the shape and structure of the hull. Their work is optimized for performance and efficiency. Second, we have the Vehicle Dynamics department. They are responsible for foiling, height control, and steering. They ensure stability and precision. Then we have the Embedded Systems department. They work on the integration of software and hardware between all the departments. Their work powers, monitors, and controls every critical aspect of our boat. We also have the Powertrain department. They are responsible for converting hydrogen into usable energy, converting sustainable fuel into high-performance power. We also have the Operations department. They are responsible for spreading our mission, building awareness, and securing the support that makes our journey possible. And finally, we have the Management department. They are the facilitators of our team. They coordinate efforts, oversee timelines, and manage resources to keep us aligned and moving forward. These departments are working closely together to transform an ambitious dream into a reality. And over the years, our alumni have laid the foundation, whose dedication and achievements continue to inspire us. By building on their knowledge, we can not only prove that a sustainable future is within our reach, but also feasible. We're also fortunate to have partners who support and believe our mission. Our partners provide resources, knowledge, and insights that make this project possible. Together, we aim to push the maritime world towards a sustainable future. And while our boat isn't in the water just yet, our design is ready. But first, let's take a closer look at how we've arrived at this milestone, how our working days have been thus far, the process, the teamwork, and the commitment that drove us forward.
We are the TU Delft HydroMotion team, and in just 1 year we design, build and test the first ever liquid hydrogen powered boat to race in the Monaco SeaLab 2025. But not only will our boat race, We'll fuel the maritime industry towards a greener future. Welcome to our journey.
Working together across our 6 departments, vehicle dynamics, embedded systems, hull and body, powertrain, operations and management, we combine our skills and insights to make this ambitious project a reality.
Our journey began with brainstorming bold, out-of-the-box ideas and defining a clear vision, mission and scope. The result? One shared goal: to prove the potential of a liquid hydrogen system as a maritime technology. Liquid hydrogen has almost 3 times the energy density of compressed hydrogen at 350 bar. This significantly reduces the required storage volume, allowing for more efficient use of space, a critical advantage for long-range maritime applications.
Furthermore, we decided to commit to foiling technology, which reduces the drag and enhances efficiency, allowing us to get the most out of our energy. And we chose to reuse the mold of our 2023 boat and optimize its successful hull design.
These core decisions laid the foundation for our detailed designs. Every nut, bolt and curve was precisely modeled in 3D. This is where our imagination meets precision and where our dreams come closer to reality.
Throughout this design journey, we've balanced limited time and resources with bold, ambitious goals. Design a boat that pushes the boundaries of hydrogen technology. Be the first ever liquid hydrogen powered boat to compete in the Monaco SeaLab 2025 and aim for victory. And ultimately, set a new standard for the maritime industry. Embrace green energy sources as a fuel of the future.
Before we reveal our design, we want to express our gratitude to all of you, our partners, alumni, and all our supporters. Thank you for believing in our mission. Thank you for being part of our journey and for empowering us to make a lasting impact on the future of maritime energy. Your support has been invaluable. And now, the moment we've all been waiting for, the unveiling of our boat's design. Over the last 3 months, every detail has been carefully considered by our departments to create a vessel that combines innovation, sustainability, and performance. However, this design represents more than just a boat. It embodies a vision for a cleaner future powered by liquid hydrogen. It is a testament to what's possible when bold ideas meet unwavering dedication. Now, we're proud to reveal the design that will take us to the Monaco SeaLab 2025.
Now that you've seen these amazing renders, Michiel and I will tell you something about the technical details of our boat. To design our boat effectively, you first need to understand what we're designing our boat for. The Monaco SeaLab consists of 3 distinct challenges, each with their own unique challenges. The first is the high-speed challenge, where we need to race a distance of 1 kilometer in the shortest possible time. A high top speed and fast acceleration are absolutely critical to perform well in this case. Secondly, we come to the maneuverability challenge. This takes place in the harbors of Monaco and involves navigating a low-speed course with tight turns, mooring and casting off, making precision and control essential. Finally, we come to the endurance challenge, where long-distance sailing is very important. For this challenge, we have to sail as much distance as possible within 4 hours, making efficiency absolutely critical. These 3 races demand very different design choices, making it a very difficult challenge to create a boat that performs well across all of them. However, we thrive on challenges, and that's exactly why we've taken this one on.
So, now that we know where we're designing for, let's first take a look at the hull, the cornerstone of our boat. Design choices were made so that it was large enough to fit all the components needed to make it propel. And our boat sails on hydrofoils, meaning the hull will be lifted out of the water completely. This means the lighter, the better. Thus, we have decided to make our hull out of carbon fiber. Carbon fiber is a composite material, and these are always made out of 2 materials. Firstly, dry fibers, in our case carbon, to which secondly a resin is added. We use vinyl ester for this. This vinyl ester hardens into a plastic-like material to end up with your composite. But not all the parts of the boat need to withstand heavy load cases, the tank caps and hatches, for example. That is why for these parts we opted for a more sustainable option, flax. Flax is a biocomposite, meaning it is produced out of renewable materials. In this case, the flax plant. This is the same plant that is used to produce linseed and linen. Composite materials already of itself have a really strong tensile strength. This is the strength in the pulling direction. The strength of composites when being bent, however, is a lot weaker. That is why we're placing foam in between the 2 carbon layers to increase its inertia of the material when being bent and making it stronger for all forces.
For the shape of the boat, we've chosen the common V shape for its excellent all-round performance. To optimize it for our specific use case, we've designed a sharp bow, which cuts through waves efficiently. And we added a chine, which helped raise the boat out of the water. For those who've been following the TU Delft Hydromotion team for a few years now, this design might look familiar. And it's indeed quite similar to the boat that's been built in 2023, which won the Monaco Open Sea class. Because it performed so well, we've decided to reuse the mold from that year. This in turn also saves material, which is especially important to us as we strive to be as sustainable as possible.
Our boat sails on hydrogen, as you know. The main advantage of hydrogen is that it is an incredibly light gas for the amount of energy that it contains. It contains 3 times as much energy as diesel for the same amount of mass. The downside, however, is that its density of itself is also really low. So you have to store it under high pressure in order to give it a high energy density. Well, we do this in this compressed hydrogen tank. It's also made out of carbon fiber, a light material, again. This is a large tank of 350 liters, storing gaseous hydrogen under the high pressure of 350 bars. This results in only 8 kilograms of hydrogen we're carrying here. But now here comes the exciting part of this year. We're transitioning to liquid hydrogen. But why? Liquid hydrogen is 3 times as energy dense as compressed hydrogen gas, of 350 bars. And liquid hydrogen doesn't even require high pressure. However, storing hydrogen in its liquid form at minus 253 degrees Celsius presents significant challenges. We cannot actively cool the hydrogen, meaning it will be constantly boiling in our tank. This means we have to limit the heat transfer from the outside to the hydrogen to prevent a pressure buildup in our tank due to evaporation. That is why we're developing a custom cryogenic tank with multi-layer insulation and a double walls with a vacuum in between, limiting heat transfer to just 7 watts, the power equivalent of an LED bulb. This system will give us the storage time to be able to test it all and to race in Monaco. This liquid hydrogen system also presents another challenge. The liquid hydrogen has to enter the fuel cell in the same form as the hydrogen gas from the gas tank. This means it has to be heated up from minus 253 degrees Celsius to 20 degrees Celsius. This is quite energy consuming, as you can imagine. That is why we've decided to combine our cooling loop from our fuel cell with our heating loop of the liquid hydrogen, using the fuel cell's waste heat to heat up the liquid hydrogen, thereby utilizing otherwise wasted heat.
So, how does the fuel cell work? Essentially, it converts hydrogen into electricity through an electrochemical reaction. Hydrogen, which is made up of one proton and one electron, enters the fuel cell. The protons are able to pass through a proton exchange membrane, while the electrons are forced to take an external circuit. This flow of electrons in turn creates an electric current, and that is what we call electricity. Afterwards, the electrons recombine together with the protons and oxygen to form water, which is then released in the form of water vapor. The electricity that is generated is then distributed to the rest of the system through a distribution box. One of the key components powered by the system is our buffer. You can think of the buffer as a very large battery made up of over 200 lithium iron phosphate cells. However, why do we need a battery if the fuel cell is already providing power? Well, the reason is that while the fuel cell excels at delivering a constant, steady flow of electricity, the power demands during sailing are constantly changing. The buffer is here to bridge that gap, charging or discharging as needed depending on power draw. This ensures that the entire system is able to operate smoothly and efficiently.
Now that we have a hull and an energy system, we need something to make this boat propel. And this propulsion is provided by an electric motor, which is connected to a drive shaft which runs through the rear strut. This mechanical energy is then transferred to a propeller by two baffle gears. This propeller is placed at the front of the rear strut to improve efficiency due to the flow over the rear foil. It's also placed at the very bottom of the rear strut. This is to ensure it stays below the water surface, even when foiling. But what is a strut? A strut can bestly be described as a long aluminium rod. There are 3 struts connected to our boat, 1 at the rear and 2 at the front, just in front of the widest point of the boat. This placement is chosen to have an optimal and delicate balance between stability but also maneuverability. The hull of itself only has a draught of 30 centimeters, but as you see as well, the foils and struts stick out a lot deeper. And as you might expect, they have to withstand large forces, but they have to be lightweight at the same time. That is why they're produced out of aluminium. They're also milled out, which makes them lighter but doesn't significantly compromise on the strength of the struts. Because as you know, weight is a really important factor, because it has a direct impact on the performance of a foiling boat.
So at this point, we're able to sail in a straight line. But come on, that's not winning against any competitions. So therefore, we've implemented a rotatable rear strut. We have built the strut in such a way that it allows it to rotate 180 degrees. Combined with the ability to reverse the propeller's rotation, this gives us full 360 degrees of steering. The most important role of the strut, however, is supporting our hydrofoils. These hydrofoils, they function much like the wings of an airplane. They are more rounded at the top than at the bottom, and at a speed of around 25 kilometers, they provide enough lift to raise the boat out of water. This in turn significantly reduces drag by completely eliminating contact between the hull and the water. The only drag that we experience comes from the air, the hydrofoils themselves, and the struts, which are partially submerged. Implementing hydrofoils, however, presents a unique challenge. When normally you've got the entire hull to maintain stability, we've now only got 3 points of contact, meaning that precise control is absolutely critical.
On top of that, the race in Monaco will be partly on open waters. So the question is not if there will be waves, but how large they will be. We design our boat so that it can foil above waves up to 0.5 meter high. In rough weather conditions, the lift produced by the foils is not constant, due to the amount of water above the foils not being constant due to the waves. Normally, this would result in very turbulent rides. if the boat would even keep foiling at all. This issue could be solved if we could control the amount of lift created by each foil. Luckily, we can. We can adjust the pitch of all 3 foils independently of each other at a frequency of 500 positions per second. But how allowing for even smoother sailing than we would without hydrofoils in these conditions. But how do we decide the position each of these foils needs to have? We cannot control the position of all 3 foils at 500 positions per second manually, can we?
No, we can't. But that's where active height control pitches in. Here is how it works. An accelerometer measures the linear acceleration in all 3 directions, while an ultrasonic sensor measures the real-time distance from the boat to the water. This data is then fed into an algorithm, which is written by ourselves, which calculates the ideal pitch positions that all 3 foils need to be at to make sure that the boat remains foiling and stable at the height that we require. The data from the height control system, along with many other components, is collected and stored by our data acquisition system. This system allows us to monitor the boat's real-time performance via an internet connection. It also allowed the previous team to share the live location and status of their boat during the North Sea crossing. The collected data is invaluable for analyzing the boat's performance and identifying potential issues. We have used telemetry from previous years to gain insight into power consumption and load cases, which have informed our design choices for this year. During the testing phase, we'll rely on our own data to validate and improve our design, ensuring that the boat is fully optimized and ready for Monaco.
We will now combine these designs, which will result in a high-performance liquid hydrogen-powered boat. And this will win us the Monaco SeaLab 2025.
Thank you.
So what happens next? From here, we embark on the most intensive stages of our journey. We move into the production phase. This is where all our ideas will come to life, assembling each component and carefully aligning every part to meet our stringent standards. After this, we'll move into the testing phase. This stage, it's critical. It's where we push our boat to ensure it achieves the highest levels of safety, reliability, and performance. We'll fine-tune our systems, evaluate the handling, and calibrate every detail to make sure we are race ready. And then it all comes together at the race in July. This isn't just a competition. It's a demonstration of what's possible when we combine teamwork, innovation, and dedication. We're not just racing to win. We're racing to set a new standard for what the maritime industry can achieve with clean energy. Before we wrap up tonight, I would like to invite the team to the stage. We want to take a moment to recognize everyone who has been a part of this journey. First, a huge thank you to our partners, alumni staff, Dreamhouse staff, apologies, alumni and family. Please join us for drinks so we can thank you in person in the foyer. And of course, a big thank you to our incredible team. Your hard work, creativity, and dedication will make this vision a reality. Tonight, you've seen what drives us and what we are aiming to achieve. This journey is about much more than building a boat. It's about creating a society we can all be proud of, a future where sustainable energy powers our world. We are the TU Delft Hydromotion team, and we are here to fuel the future.